Dr. Hovind, I love your doctoral thesis. I've torn it to pieces with house and gaffle. I can't remember when I last pissed myself laughing. It's a good thing the thesis mopped the piss off the floor.
Welcome to part 65 of this read-through and peer review of Kent Hovind's doctoral dissertation, which was published on wikileaks.org on December the 9th, 2009. If you have not yet seen the first parts in this series, then I recommend that you go back and see those first, as in this episode I will start off exactly when I finished off in the last. In the last episode, Kent started to tell us how the age of coral reefs off the coast of Australia can give us an indication about the age of the Earth. Of course they don't, but this doesn't stop Kent continuing in this episode. Enlighten us, Kent. Food would have been readily available with all of the rotting carcasses of the vegetation and animals. The coral would have grown much faster under these conditions. Then it would have slowed down to its current rate. Actually, Kent, quite the opposite. The optimum conditions for coral are clear, shallow waters with plenty of sunlight. If the flood had have occurred, as you like to assert, then the water would have been much, much deeper, and there wouldn't have been any sunlight, and the water would have been murky. What's more, as the detritus came out of suspension from the seawater, it would sediment over the top of the coral, killing it. So it kind of blows your argument completely out of the water. Do continue. People who have studied coral reefs say that they could have been formed in 4,000 to 5,000 years with no problem. Yes, Kent, that is actually correct. Well done. The majority of today's coral reefs formed after the last great ice age. As the snow and ice melted, the sea level rose, and in tropical areas, the sea flooded the continental shelf, which created an ideal habitat for coral. The Great Barrier Reef, for instance, is 6,000 years old. However, there are coral reefs that can be dated as far back as 170,000 years old. And there is fossil evidence for coral that dates back 500 million years. But anyway, if the Earth is older than that, why aren't the coral reefs much larger? The rate of growth indicates a young age for the Earth. Yes, Kent, only if you count the ones that are no older than 6,000 years. But anyhow, I'll let you move on. The bristlecone pine trees, the red trees, and the sequoia trees in California. Yes, Kent, what about them? Did you think that because you were foreshortening the age of the Earth, you'd also foreshorten that sentence? Go on. The guides in California say that there is no reason that any of these trees should ever die. Yes, Kent, but they do though, don't they? Apparently they will live until some disease attacks them. If they are protected from disease, they will just keep on growing, adding a ring every year. That's right, Kent. And you know what's funny? There are examples of bristlecone pines. There's one called Methuselah, for instance, that are nearly 5,000 years old. Yes, Kent, that's older than the flood, which means that these trees must have survived the flood, if it ever really happened. And what is even more amazing is that scientists using tree rings, or rather the principle of overlapping tree rings, are able to count back as far as 10,000 years. That's between 3,000 and 4,000 years older than what you insist, is the age of the Earth, but I'll let you continue. One way, of course, to tell how old a tree is to drill a core sample and count the rings. By the time a tree is 100 years old, it is not quite 1 inch in diameter. To count 100 rings in a ½ inch is difficult and must be done with a microscope. Yes, Kent, like I said. Counting rings is a little more difficult than just sawing a tree down and looking at it. Yes, Kent, because you've also got to be able to count. And in the case of bristlecone pines, you've got to be able to count to a very high number indeed. The bristlecone pines indicate an age of about 4,000 years maximum. Yes, Kent, apart from those that are older. If the Earth is millions of years old, why don't we have a 50,000-year-old bristlecone pine tree someplace, or a ½ billion-year-old? Well, that's simple, Kent. You said it yourself. They die of various diseases. Don't you actually read what you've written? No, you don't, do you? Okay. Carry on. The age of the oldest living thing in the biosphere, the bristlecone pine, indicates a young age for the Earth. Yes, Kent, apart from the ones that don't. And by the way, the bristlecone pine is not the oldest living organism on the planet. That honour goes to the creosote, but there is a particular example in the Mojave Desert that goes back 11,700 years. Going by your figures, that's twice as old as the Earth. But whatever. The evolutionists don't look at that one because that doesn't support their theory. Actually, Kent, they do, and it does. You see, a species that is so long-lived takes an extraordinarily long time to evolve. You really should stop using examples, Kent, that when looked at in detail, completely destroy your argument. It kind of makes me think that you haven't really done any research other than comb through Institute for Creation Research technical papers. And we all know, based upon the number of technical papers and published articles that they publish in proper scientific journals, that they don't do any research whatsoever. But I'll let you continue. The pressure in oil wells in Texas is another indication that the Earth is young. Really, Kent? Now this one should be very good indeed. I lived 5 years in Texas. You lived in the same state that W came from? No wonder you're retarded. I saw a flame shooting up in the sky one night and went over to investigate. There were some men burning off the natural gas as they were drilling an oil well. I began asking them questions, talked about the oil there in Longview, Texas. They told me that they had a blowout protector, that they put about 1,000 feet down in the ground in case they drilled into a pocket of pressure. 1,000 feet, you say? Continue, Kent. I asked them what kind of pressure they were talking about. How much pressure is the oil under down there in the ground? When drilling down about 3,500 feet, often the oil has 20,000 pounds of pressure per square inch. Really, Kent. And exactly what do you expect with a kilometre of rock on top of it? And did you by any chance talk to the site geologist about how that kilometre of rock ended up on top of it in the first place? And precisely how many of them told you to bugger off when you told them that you thought that the world was only 6,000 years old and the oil was there because of the flood?